All right, we're on the review packet for 10.9, 10.10, and also solving systems of equations with story problems. So as we jump right in here on number 1, you can read in the directions. We're going to solve by graphing. We've got something that's to a power in terms of our x, so that is not going to be a straight line. We're going to use our graphing calculator to see what it looks like. Find the intersections, and that is going to be the solution to this system. The points that these two functions or equations cross, those are the points that solve the system or solve both of those equations together. Now, you'll notice all of these graphs are a little different. Okay, these three happen to be the same, and they all go from positive 10 to negative 10 for the x and the y, but they count by 2's, so we'll have to adjust our window properly so we can sketch that correctly. And on number 1, our minimums and maximums are 8 and negative 8, and it is counting by 1's. And so we need to set that correctly in order to graph this. So as we go to number 1, we can go ahead and punch these in. So it's x raised to is right here. Raised to the third. And y equals x. And if I graph this, if I had reset my calculator and I'm just in my standard zoom, I have this all the way up to positive 10 and negative 10 if you count them on my x's and my y's. What you want to do is you want to click on window and you're going to adjust those. So my x minimum, if I clear this out, should be negative 8. My x maximum should be positive 8. I do want it to count by 1's, even though I see numbers 2 and 4, each line is worth 1. So my x scale should be 1. My y maximum and y minimum should also be 8 and negative 8, and they're also counting by 1's. So now if I graph it, it looks exactly like I want. Okay, so this comes up. It looks like it's a little bit in between the first and the second when it comes up. Crosses at 0, and then it's going to do the same thing on this side. It's going to get past 1 pretty quick and then shoot up. And it should be fairly straight. Again, this is not the most important part, but we want to get a fairly accurate sketch here. And so this line that crosses, we need to see that it hits in 3 different places. That's the important part. So it's going to hit here, what appears to be 0, 0, and here. So when we go ahead and find our solutions, we're going to need 3 of them. We're going to write them as ordered pairs, x comma y. And so to find the intersections, we're going to use our calculate function. So second, and the trace button, which gets us to calculate. We want the intersection. Okay, and it's always going to ask me to identify the 2 curves that I want to know where's the intersection. Now I only have 2, so I can hit enter for first curve, enter for second curve. And I'm going to go ahead and just leave it where it's at right now and hit yes for the guess. And 0, 0, sure enough, is the intersection. So let's try it again. Second, calculate, intersection. First curve, second curve, hit enter, enter. But now scroll over for your guess and get close to the intersection over here. That's 1, 1. And let's do it one more time. Second, calculate, intersect. First curve, second curve. Now for this guess, I'm going to go over close to this intersection, and that's negative 1, negative 1. And the order that you list those does not matter. Okay, so going over to number 2, I'm going to go to my y equals, and I'm going to clear these out. Make sure you can see the whole calculator. So we got 4x plus 1 and 4x squared plus 1. Now, my graph, in terms of my zoom and my window, are still on that positive 8, negative 8. So if I go to my window, I need to change these to negative 10, positive 10, because that's what my maximums and my minimums are. And each line is worth 2, so I need to change my scale, my x scale, to 2, negative 10, positive 10 for my y minimum, y maximum, and my scale is 2. Now my graph is going to look like this. Okay, so starting with my parabola here, it looks like it stays pretty much inside here and goes just under the 2. And then it's going to do the same thing on the other side. Scoots up. And there's going to be two intersections here. Good enough for the sketch. Now, second, calculate intersection. First curve, second curve, hit enter, enter. And now it's already sitting on my intersection right there. So that's my first one, 0, 1. Go through it again. Second, calculate, intersect, enter, enter. And now for my guess, I'm going to scroll over to where I see the intersection. Hit enter, and it is 1, 5. All right, let's put the new y equals in here. Clear these two out. So 2x, I'm going to hit the raise to the third. Now I got to scroll sideways to get off the exponent. Plus 2. We don't want that plus 2 up in the exponent. And then 8x plus 2. Now this graph is going to be the same in terms of the window settings. Positive 10, negative 10, counting by 2's. And so with this window, it looks something like this. And then I'm only going to see one intersection. But I can clearly see if this line continues, the red one, it will hit eventually. So when I go to do my intersections here, I need to adjust my window so that I can see all three intersections. So I'm going to go to my window. Let's go back for a second. I need more y values. Like if I could see more to the right and to the left, that's not going to help me. I need to see farther down and farther up. Those are y values. Right now my y value is 10, my maximum. So if I increase that in my window, my y maximum, let's make it 20, and my y minimum negative 20. And that's just guessing. Okay. I'm going to graph it. Now I'm going to see higher up and farther down. And clearly I can see all three intersections. So now when I do second calculate, 5 for intersect, first curve, second curve. Okay, my intersection right there is 0, 2. Let's do it again. Second calculate, number 5, first curve, second curve. And now I'm going to scroll over for my guess close to this one. And it's negative 2, negative 14. Which you can see was not going to be on my original graph if it had a y minimum of negative 10. I had to go all the way to negative 14 to see it. And then one more time for the last one. Second, calculate, intersect, first curve, second curve, slide all the way over here for the guess. And it's 218. Okay, last one. Graph settings are good. Let's just go to y equals, clear these out. Y equals 1. We should know what that looks like. It's going to be a straight line hitting at 1. So I can go ahead and draw that. I already know what that looks like. And then x to the 4th. Go to my graph. There's y equals 1. And now I readjusted my minimums and maximums. So actually I do need to go back to my window. My x minimum and x maximum are good, but I need to go back and fix my y minimum and y maximum since I changed them on the last one to see it. And it's going to be a little bit clearer. Okay, coming down, intersect, something like that. Again, the sketch doesn't need to be perfect, but we want it to be somewhat respectable, right? We don't want to just scribble. And now I'm going to go ahead and second, calculate, intersect, first curve, second curve. Now for guess, I need to slide over here. That's negative 1, 1. Second, calculate, intersect, first curve, second curve, slide all the way over. Close to it, hit enter, and that is 1, 1. So as we flip the page over, we're going to be looking at these story problems. These are all systems, so we're going to be writing 2 equations. We'll talk about y in a second. So Eugene and Dan each improved their yards. They planted hostas and ornamental grass. Hostas are types of flowers and some grass. They bought their supplies from the same store, so the prices were the same. Eugene spent $102 on 10 hostas and 4 bunches of ornamental grass. Now, right there you can write an equation. We don't know how much the hostas cost and how much the grass cost, but we know he bought 10 hostas, 4 bunches. Total cost was 102. So if I did know the price, I would multiply it by 10 because he bought 10 of them. So I'm going to call that 10H. And if I add on the price of the grass, so 4, and I'm going to use G for grass, depending on how many hostas and how many ornamental grass pieces he bought, I'd multiply to get the total cost, and he spent $102. Now, if this is the only equation I have, I cannot solve it. I can come up with different numbers that work, multiple answers here. But if I want to actually find out the correct price, I need to compare it to the other person. I need another equation. Right now, if I solve this equation for one of these variables, I'm still going to have the opposite variable still in my equation. And so to eliminate one of them, I need to either use substitution or elimination. So I need to write another equation here. So the other guy, Dan, he bought 9 hostas, and I'm going to line these right up, and 8 bunches of grass, and he spent $105. So now that I have a second piece of information here, I can find out the exact number here. Because for this first one, you could make up a whole bunch of different things. You could say the hostas cost $10. 10 times 10 would be 100. So we would have spent $100 on hostas, and then you could figure out, oh, it's 50 cents for the grass. But you could say, well, maybe it's $5 for the hostas. So that puts me at $50, leaving me 52. Divide that by 4, and you could figure out, okay, the grass maybe costs this. So you could come up with a whole bunch of different combinations here for the hostas and the grass. But now that I have another scenario setting this up, another equation, I can find the exact price, not multiple combinations. There's only one combination that's going to make it true in both of these situations, which means that's the actual amount. Now, you can use substitution if you really want to, but you'd have to move one of these to the other side, divide. You're probably going to get some goofy numbers. This is one of these ones that I definitely want to use elimination for. So I'm going to multiply this one because I see the 4 and the 8. I'm going to multiply it by -2 because that'll create a -8, which will cancel right here. So bringing this down and multiplying. So -20H when I multiply it times the 10, -8G, which is what I wanted. Now these will cancel, and -204. Now I can combine these. The G's will cancel. So I'm going to get -11H, and 105 minus 204 gets me -99. Divide that by -11. 2 negatives make a positive, so H equals 9, and this is the price, so $9. Now I'd ask you for the cost of one hosta, we got it, and the cost of the ornamental grass. So since we don't have the G yet, we need to go back and plug it in. You can go back to either one of your originals. I'm just going to go back to the first one. Plug in for H. We know it's 9 now. So $90 were spent on hostas. You're going to minus the 90 from the 102. So 4 pieces of ornamental grass came to $12. Divided by 4. The grass was $3 each. Okay, number 6. We have a field trip. As you read through it, you'll see they're taking buses and vans. This first school, they had 7 vans and 7 buses, and that was 406 students. High school B has 12 vans, 14 buses, 784 students. Each van and bus carried the same number of students, so how many students can a van carry? How many students can a bus carry? So we have to solve for both. So again, I'm going to multiply this one. I see a 7 and a 14. So again, I'm going to multiply by -2 to create a -14. So -14V, -14B, and that's the magic one right there. That's going to cancel. And then 406 times 2 would be -812. So now I can put these together. I get -2V. The B's cancel. And 784 minus 812 gets me -28. So when I divide by -2, the vans hold 14 students. Okay, if I want to know how many people are on the bus, I'm going to go back and multiply in my 14. So plugging into this first equation, v becomes 14. So 7 times 14 is 98. And I'm going to take the 98 off the 406, leaving me 308. So 7 buses carried 308 people total. And so when we divide by 7, we find out that the bus carries 44 people. All right, number 7. School is selling tickets on the first day. 4 adult tickets and 4 student tickets were sold for a total of $56. So 4A plus 4 student tickets. I'm going to put T for students because S tends to look like a 5 for me, so I'll use T. You can use whatever you want. Equals 56. Then the school took in $56 on the second day. So they took in 56 on the first day, 56 on the second day, but on the second day they sold 8 adult and 1 student ticket. So very different. Both days came out to 56 with different combinations of tickets. Now, when I go to solve this, if you wanted to use substitution here by minusing 8a from both sides, it would say t equals negative 8a plus 56, and you'd plug that in for t. You could do that. I'm going to continue working the way we've been working. Now, some of you might multiply this one by negative 2 to create the negative 8. Perfectly fine. I saw that I could make this into a negative 4 real easy, so that's the way I'm going. But either way is fine. So this is negative 32a minus 4t. That's the one that's going to cancel. And 56 times 4 is going to be negative 224. Now, if you do stack it up like I'm stacking it up, you got to be careful. Don't go back to the one right above it. That's the one we changed, so we're going back up here. So it's 4 minus 32. That's negative 28a. Positive 4 and negative 4 cancel. That's what I wanted. And 56 minus 224 is negative 168. So we're going to divide by the negative 28. And we find out that a equals 6. So I'm going to go ahead and go back to the second one since there's less going on there. So 8 times 6 plus t equals 56. All right, so I'm going to get 48 plus t equals 56 minus the 48. And t equals 8. So student tickets are $8, adult tickets are 6. And number 8, they're selling fruit. We have small boxes and large boxes. So he sold 8 small boxes, 2 large boxes for a total of 142. So 8 small boxes. You could use an S. I'm going to go ahead and just use X and Y here, and I'll define them over here. So X is small, Y is large. If you're not going to use letters that make sense with the problem, define them. So 8 small boxes plus 2 large boxes equals 142. The other person sold 4 small, so 4X, and 4 large, 4Y, for a total of 128. Very similar to the ones we've done. We can multiply this by negative 2 to create a negative 8, or we can multiply this by negative 2 and create a negative 4. That's what I'm going to do. So distributing here, negative 16x, negative 4y, that's what we wanted. And 2 times 142 should be 284. It's negative. So straight down now, this is negative 12x. The y's cancel. 128 minus 284 is negative 156. We're going to divide by 12, and x, which is the small, are going to be $13. Go back and plug that in to either one. I'll go back to the second one. So 4 times 13 is 52. We're going to go ahead and take the 52 away from the total of 128. So that's 76. And now dividing that by 4, we find out that the large boxes are $19. Okay, moving on to the graphing. We're going to have some shaded regions here because we have inequalities. These on the first page are all in y equals mx plus b form, so we've got the slope and the intercept. So starting at my intercept of 5, I'm going up 9 over 4. Remember, it's always over to the right. And so since that's not going to fit on my graph, I like to put this reminder so I work my way back this way. As I go down 9, I don't go over 4 this way and create a negative slope. It's a positive slope, so it needs to be going this way. So I'm going to go down 9, so I went down 5, down 4, that's 9, and then over 4. And so this line's going to look like this, dotted because there's no equal sign. This one starts at negative 7. It's going down 3 over 4 right there. And if I went up 3 and over 4, I'm going to hit right here. So it looks like this. And now I got to go back. So my one that hits at 5, it says less than. Okay, y is less than. So less than for y values is everything underneath this line. So it would be this whole region and this region here. All of that, if this is my line, would be shaded. It goes underneath, everything underneath that. These two regions up here would be greater than. So everything under is less than. So it's one of these two regions. It's either greater than this region, so it's up here, or it's less than this region, so it's down here. And so this one, the one that starts at negative 7, says y is greater than. So the numbers greater than negative 7 are going to be above it. So it needs to be less than this, greater than this. And so my shaded region is everything in here. Number 10, starting at negative 5, I'm going up 4 over 5. And this is solid. Okay, my other one starting at positive 2, down 3 over 5. There's my intersection. Also solid. First line that hit at negative 5 says greater than, so that's everything up above this line. So it's either this or this, depending on this one. This one says greater than, so we're looking up above this one. And so it needs to be above this and above this, so that region would be up here. Number 11, starting at 6, up 5 over 2. Can't get to it, it's up here. So when I work my way backwards, I need to make sure I go to the left. So I'm going down 5 over 2, down 5 over 2, down 5 over 2. And that would be a solid line. Other line starts at negative 3. Slope is negative 2 over 1, down 2 over 1. Okay, I don't need to go too far this way. I really need to see my intersection. Up 2 over 1, up 2 over 1. There's my intersection. Like this, also a solid line. Going back to the first one, it says y is greater than. So from 6, that's everything on this side of the line. This is greater than. So it's going to be on that side of the line, so I know it's not here, it's not here. It's one of these two. So based on this line, it says y is less than. So here's my negative 3. Less than is down this way. So again, down this way. Okay, I already said it's not this one. It's not this one. This is my shared region that's less than this but greater than this. Number 12, let's jump straight to here because it's not a y, it's an x. So x is, think of this like x equals 2 for a second. The line's going to look the same. It's going to be dotted, negative 2. So I go to negative 2 on the x-axis. It's going to be the line that goes straight down through it. And since it says less than, all the x values less are this direction. Okay, so I'm going to have shading to the left of this. This other line hits at negative 5 and goes down 3 over 2. up 3 over 2. So there's my intersection, up 3 over 2. And this one's also a dotted line. So we already said it's got to be, it can't be out here, it can't be out here, because it's got to be less than or to the left of the x. Looking at this one, it says y is less than the -5. So here's the -5. It's got to be less than. So going this direction, we know it's not in here. So less than would be over here. There it is. Okay, well, as we flip to the back, it's exactly like we just did, except these are not given to us in y equals mx plus b form. We got to get it there, which means get y by itself. So I'm going to minus x. So negative x minus 16, divide by the 4 to get rid of that. I divided by a positive, so no flipping. Greater than or equal to negative 1/4 x. That's a 1 up there. Negative 4, so I'm going to hit at negative 4. And my slope is down 1 over 4. So going the other way, up 1 over 4. Solid line there. This one will be a dotted line. First thing I do is move this. So minus 11x on both sides. So I'm left with, got to keep that minus sign, negative 4y, which means when I divide, I need to flip. Greater than negative 11x minus 32. So divide by negative 4. So we got a lot going on here. These cancel. Dividing by negative flips this. 2 negatives make a positive. Can't simplify it, so I leave it 11/4 x. 2 negatives make a positive 8. So I'm hitting up here at 8. I'm going up 11 over 4, which again would be this direction. So as I move down 11 over 4, I got to go this way to keep that a positive slope. So I'm at 8, go down 8, 3 more to make 11 total over 4 this way. So here's my intersection. It's a dotted line. Okay, going back to my first one, you got to go back to your final answer to look at your shading. This said greater than, so greater than this line would be up. So it's one of these two regions. And this one says less than the 8 would be over here. So it's not this region, less than would be over here. So that's what we're looking at there. Moving on, minus x over here. So 6y greater than negative x minus 36, divide by the 6. Y is greater than, no flip because there were positives, negative 1/6x minus 6. So I go to negative 6, and I'm going down 1 over 6. So up 1 over 6. That's a dotted line. And my other one, I'm going to minus 3x on both sides. So that leaves me 2y. So no flipping here. Divide by the 2. Even though I have a negative in the problem, I'm not dividing by a negative, so there's no flip. Y is less than or equal to negative 3 over 2x plus 2. So starting at positive 2, I'm going down 3 and over 2. So there's my intersection right there. This is a solid line. Something like that. Okay, going back to the one at negative 6, it says greater than. So greater than is up. So it's one of these two regions. This one, there was no flip. It says y is less than, so it needs to be under this one. Okay, so that makes it this region. (15) minus that x on both sides. This one's nice because the y has a coefficient of 1 already. So we are done here. We can go ahead and plot it on the graph. So starting at 5, slope of negative 7. So that's down 7 over 1. So 5, 6, 7 over 1. It's a dotted line. And the next one looks like the y is by itself, but that's a negative one, so we will have to fix that. So we're going to minus 2x. It's going to leave me a negative y, which I'll have to fix, greater than negative 2x plus 4 is a positive 4. Now I got to divide by negative 1 to put this on the graph. I need a positive y. Because I divided by a negative, I got to flip this. Two negatives here make a positive slope of 2x. This makes a negative 4. So I'm hitting at negative 4. And I'm going up 2 over 1. So there's my intersection, boom, right there. Up 2 over 1, up 2 over 1, up 2 over 1. That's going to be a dotted line. So both of these are dotted. Going back to my endpoints here, so the one that hits at 5, it says greater than 5 is up this direction. So going up from that line, it's one of these two. Looking at this one, this says less than underneath this line. And so my shared region is everything out here. Okay, last one, minus the 5x on both sides. This one's done, so start at 1. Slope is down 5 over 1. So up 5 over 1 going this way. That is a solid line. This one, minus that x on both sides. So we are starting at 5. Slope is negative 1. That's negative 1 over 1, down 1 over 1. So it's going all the way like this, so my intersection is right there. This again is a solid line. All right, these are my two. So the one that hits at 1, it says y is less than. Less than 1 is going down this way. So all of my shading would be this way. So I'm either up here in this little piece, because that also would be underneath this line, less than. Okay, or it's this big region out here. So it's either on top of this line or underneath this line. This is y is less than, so it needs to be underneath, which would be this nice big region out here.